Hello and welcome back to another episode on how to make your own LED wire tree. My name is WorldEdit and today I'm going to show you how to solder the LEDs to the wires. And I've upgraded to a new camera mid-episode, so I've already made a bunch of LEDs here. And I'm gonna show you this later in the time lapse. But yeah, now let's get started. And this is probably a good time to think about how many LEDs you would want to make. So I am using these white LEDs, and as you can see they have 3 volts and 20 milliamps, and I'm gonna wire 3 of them in series. And so my power supply has 12 volts, my LEDs have 3.3 times 3 LEDs in series is 9.9 volts. And then I'm going to use a resistor, and there is 2.1 volts left. So now we're going to calculate how much current is going through that. So the current is the voltage squared divided by the resistance, and the voltage squared on the resistor is about 4.4 divided by 390, which I'm using as a resistor, and this is roughly 11 milliamps. So the LEDs are powered about halfway to full power, so this is okay. And this is on the 12 volt setting, and if I set the power supply on 9 volt, then we'll get a nice dim setting for mood lighting. So this is okay. But what if you use red LEDs or green LEDs? Well, the reds probably have around 1.5, 1.6 volts, so you can wire 6 of them in series. And with the green ones, it's probably around 2.5 volts, or 3 or 4 in series. But I'm going to use white ones with 3 in series. So I will make a multiple of 3 of LEDs, and I think I'm going to make 63 or 66, I don't know yet. Okay, let's get started with that. And well, first we're going to need a way to test our LEDs. And for that I'm going to show you how to make a little LED tester. We could use our multimeter here, but I don't know if you guys all have a multimeter, so I'm going to show you how to make a little tester. And for this I'm going to use 2 of my 390 ohm resistors and an old discarded 9 volt battery. And it doesn't need a lot of juice left, just a little bit to power the LEDs. And for the resistors you can probably use anything between 300 and 1000 or something, it doesn't really matter. And what I'm going to do is solder one of these resistors to one side. Let me just grab that here. So I'm going to solder this resistor to this terminal here. That's okay. And then I'm going to take the other resistor, solder it to the other side. It's not so easy doing this on camera. So this is good enough for our purposes. So these two resistors are now attached. And now I'm gonna take some heat shrink just to insulate everything a little bit. It's not really necessary, but if you get the two wires touching, then the battery will discharge and then you will have to make a new LED tester. So let's just shrink this. The other side. Now I'll use some bigger heat shrink for the down at the terminals. Good. No, it's too small. Let's use something a little bigger. All right, and now this thing is finished. We have the bigger terminal here, which is the negative side. And if we now take a look at our LED, then you can see that inside it has a bigger part and a smaller part, and the bigger part is always the negative pole. And you can also see that there's a rim outside the LED, and on this side it has a flat side, and this also indicates the negative pole, if you're wondering. And now if we take our LED tester, negative to negative, and then the LED lights up. Now it's great, the LED tester works, and we can put that away. Okay, now let's start soldering the LEDs. So I'm just gonna take one and put it in my third hand here. And now I'm gonna tin the legs, and the shorter you make the legs, the faster you have to be with the soldering. At this length, it's probably about half a second till the LED melts and dies. And if you make them a little longer, you probably have 1 second. So just very quickly put some tin on there. And it's of course better if the soldering iron doesn't go into standby halfway. So now I'm going to take a wire, also tin this wire a bit, and then as quickly as I can make a halfway decent connection here. So now this wire is on. Now I'm going to take the green wire, same process. Black wire to the negative terminal, green wire to the positive terminal, and it's done. Okay, now I'm going to take two little pieces of shrink tube and feed them through the wires. Feel free to put it on the wires before soldering, but I always forget that. So all the way up there. And it's not necessary to put heat shrink there, but it just makes everything a little bit safer. So if the LEDs touch on the tree, then you won't get a short. And now if you get a short, then a few LEDs will turn off, and that will be very annoying. So what I'm going to do now is take the wires, hold them in my hand, separated like this, and then I'm going to twist on the LED until all of the wire is twisted up. And later on the tree you can't see that, but this will make it really nice and easy to handle. So now you always know which wires go together, and you don't have to measure and test everything. And now we need to see if the LED survived the soldering. So big terminal to the black wire, small terminal to the green wire, and the LED works. Okay, so this one is finished now, and I'm gonna just put a very small piece of heat shrink on the end to keep this together until I'm ready to wire it up. So this is now finished, and I think I have probably about 10, so I'm gonna need to make a lot more, and yeah, I'll cue the music and enjoy the time lapse. I'll see you after that. Now, while the time lapse is running, I just want to quickly talk to you about quality control, because that's essentially what we're doing, testing each LED with the LED tester. And we're not only checking that the LED works, we're also testing that the right color of wire is on the right terminal. And that might seem a bit boring, but if we test everything along the way, well, we will later connect everything up and everything works. And trust me, boring is good here, because when you connect everything up and you haven't tested everything along the way, then you have no idea where the problem is. If anything doesn't work, you have to rip everything apart and test everything again, and that's really annoying. So bear with me on this one, do testing thoroughly. And the LED tester didn't really work too well. I had to resolder it in the middle, but yeah, you should test the LED tester. It's like testception here, and take a fresh LED and test if the LED tester is working. Okay, so now I'm really gonna cue the music. See you later. we are now down to the last LED, and this took a very long time because well, this is the most lengthy process of the whole build, and took me several hours just soldering and making new wires and so on. And then I ran out of heat shrink and had to order new stuff. And also the LED tester didn't work very well, so yeah, and I also bought a new camera halfway through the video. So I hope the quality is much better now. Damn. Soldering iron is always going into standby, I don't know why. So I have 65 LEDs now behind me, or in front of me rather. And I didn't have a single LED that failed when I soldered it. So yeah, that's very good. I still have a few spares, but well, I kind of wanted to show you guys what happens when you mess up the soldering. And I'm sure I got pretty close a few times, because sometimes it took me a bit long to get the soldering done. But yeah, the LEDs all work. So let's just test this last one here. Yeah, it's also good. So I think what I'm going to do now is just show you what happens when you solder too long. So I'm gonna put that away. Gonna take a fresh LED. Put it in here. And we can see that it works at the moment. All right. Now, I don't know how fast I'm really soldering, and I will look at the footage and tell you exactly how long I usually take. But now let's first try about 1 second. Okay, it was about 1 second. And it's not only the time that determines if the LED lives, but also if you make a very big blob of solder on it, this will have a lot of heat stored in it, and then that might destroy the LED. So now it's still working. Okay, let's ramp this up a bit, maybe about 1.5 seconds. Okay. Still working. Oh, that's a hardy fella here. Okay, let's try it 2 seconds. Now it must be gone. Still working. Son of a diddly. 2, 3. And it is still working. Unbelievable. All right. This is the negative terminal. Let's try the positive terminal, because it has a, as I shown you, it has a smaller part inside and it will get hot more quickly. Okay. 1 second. Still okay. Two seconds. Okay, now it's dead. So the positive terminal can take a lot less heat than the negative terminal, and you can see the multimeter doesn't do anything either. So this LED is gone now. Okay, I think that concludes the video. We have destroyed one LED for science, and If you like what I'm doing, please like, comment and subscribe. And in the next video I'm going to show you how to prepare the base and put all the wires through the lid. And yeah, see you then. Bye bye.